Okay, meantime, since nowadays, if that, we have started our online class quite some time already lah. So I think you all should know the rules of the Zoom already. So since if let's say you don't like to write inside the chat room, you can always unmute yourself to ask any questions or answer my questions. Okay. Then remember, once you finish talking already, then you unmute back. You mute back yourself. Then it will okay already. Okay, can I? Okay, I think it should be okay already. One more thing, 5 beta, please tell your friend, okay, for example, Jess and Joa, then Bessing Yi and Sherry. I realized that I think see them for quite some time already. So please ask them to come. Sherry is here, sorry. Okay. I think Joa and Jess, they didn't come to my class for quite some time already. So if let's say they have any problem, please ask them to come to tell me, okay? Wi-Fi problem, data problem, or any laptop problem, okay? You can ask them to come and find me, okay? WhatsApp me, then I will try to solve for them, okay? Can I? Okay, good. Okay, so now for 3.3, we will have the last part is the application of electromagnetic induction, which I started a little bit last lesson. Okay, so for this electromagnetic induction applies in our generator. Okay, generator can be found in, if let's say you go to any pasar malam, okay, then they want to on the light, anything, they will pull something, then it will generate the electricity already. That one is the generator. Okay, can be either a DC generator or AC generator. Okay, not only that, okay, we were in our daily life, okay, for electricity, okay, if let's say we are not using the combustion of the fuel, we will use hydro energy or wind energy or maybe geothermal heat energy. Okay, those energy, it will help to produce a motion, and this motion, it will induce current, also based on this concept, electromagnetic induction. Okay, so we will look at one by one how a DC generator and AC generator induce current, okay, using electromagnetic induction. Okay, so now let's continue. Okay, so this is why I let you see last week. Okay, the difference between DC generator and AC generator. Okay, I look at the similarities. For similarity, both generator, they will have a permanent magnet, a pair of permanent magnet inside. Okay, then they will have a coil over here. Okay, and this coil is made out of insulated copper wire. Okay, they will coil a lot of times already make it like this. Okay, or we call it not coil, but it's maybe we will call it as armature. Okay, armature, and this is the one that it produces the force to induce the current. Okay, then here we will have commutator. We have two types of commutator. Okay, one, it will be the okay, this we will call it as split ring commutator. Okay, and this we will call it as slip ring commutator, slip ring commutator, and it will be connected, okay, to a carbon brush. Okay, this part is the carbon brush. Okay, carbon brush, and this carbon brush is where you connect everything, okay, using wire to a galvanometer. Okay, because in a basic one, we will use galvanometer to check the presence of the current and which direction the current is moving. Okay, so when the coil is in horizontal, the induced current is maximum, which means that, okay, the coil will move like this. Okay, this is horizontal, this is this is vertical, and this will be horizontal. Okay, this is vertical, this is horizontal. Okay, so when the coil is moving in the horizontal, is at the horizontal, so the induced current is maximum. Okay, why? Okay, later I tell you. Whereas if let's say it's a vertical, the induced current is zero. Okay, why is it the vertical part, the induced current is zero? If let's say your coil is like this, okay, so which means that it's moving here and there. Okay, it's moving left to right, which is in the same direction as your magnetic field line. Okay, your magnetic field line, as you can see, over here, it is moving north to south, north to south, north to south. So if let's say your coil is in vertical, so which means that it has a tendency to move left to right, which is parallel to the direction of the magnetic field line. So there is no cutting of the magnetic flux. Remember, the cutting of the magnetic flux only available when your coil is moving in a horizontal. Okay, why is it in a horizontal? Because if let's say it's in a horizontal, this coil is moving up and down, up and down, up and down. So if let's say it's moving up and down, it is perpendicular to the direction of the magnetic field line. So which means that it is cutting the magnetic flux already. It is cutting the magnetic flux. So cutting of the magnetic flux, it will induce current. Okay, Asa? Understand? Okay, good. Yeah. So let us continue. Sorry, my Elsa, she wants to see me today. So I don't know. I have to bring her in. Yeah, forgive me if let's say Elsa is disturbing. Okay? Okay. So generator is actually using converting a kinetic energy, which means that the turning of the coil into electrical energy, which is fulfill our concept of the electromagnetic induction. You have a force, then it will induce a current. Okay, so make use of the electromagnetic induction to produce an output voltage. Okay, Emma, okay. Make use of the electromagnetic induction to produce an output voltage. Okay, output voltage is for maybe to light up a bulb in a bicycle, so using a dynamo. Okay, so the coil is rotated by external force and cuts the magnetic flux. That's why if let's say you were to look into how they operate the generator, they need to pull something first. Why they need to pull a wire out? Because when it's pulling, is providing the external force for the coil to start to move. Okay, the coil to start to turn. When the coil start to turn, then only it will induce current. Okay, so the difference of the DC generator, okay, DC stands for direct current, means that the current flows in one direction. For AC, which means that it is alternating current, which means the current is flowing in the alternate direction. Okay, why is it will make the difference between DC and AC is because of the commutator that is connected to it. For DC generator, a split ring commutator is connected to it. Then for AC generator, 2 slip rings is connected to it. Okay, so now we will look into it, how a DC generator and AC generator are different in using electromagnetic induction to induce current. Okay, so I let you see a video first about DC generator. Okay, then I will explain further.
Hi and welcome back to my YouTube channel. Have you ever wondered how DC generator works? And what are the basic parts of a DC generator? This video will give you the answers to these questions. We will start with the basic parts of the elementary DC generator. As you can see, the configuration of DC generator is pretty simple. The stator is a fixed part of the DC generator.
So you have a pair of permanent magnets.
2 of them at north and south poles, which is placed to fit around the rotor. The main function of the stator is to provide the magnetic fields to which the rotor armature coil is rotated.
Okay.
Armature loop are generally placed in slots of armature core. The armature
coil the loop and the coil and also the spinning part is just an extra information for you.
Several coils in series.
Okay. It just want to tell you that the coil is in a lot of coil using insulated copper wire to produce armature.
The split ring is a
this is the part that why a DC generator produces direct current. The reason is a split ring.
We must use the split ring to achieve single direction of current. The brushes are made of carbon. These are rectangular bowl-shaped. The only function of these carbon brushes of DC generator is to collect current from commutator segments. A galvanometer generator is an analog electromechanical actuator that produces a rotary deflection of some type of pointer in response to electric current. So how does the DC generator work? Firstly, we don't want that current direction to change. We want it to remain the same at all times.
So the current will flow in one direction.
So how do we do that? Now, to make sure that the current direction remains the same, what we require is that these brushes constantly keep changing contacts between these wires for each half of rotation. So if the current flows in this way, in this position, this brush must be connected to this wire. So current flows like this and comes out.
One part screw will be in, one part screw will be
you can
out.
see that when the coil comes to this position, the direction of the current changes. If we want to keep the current in the same direction, we must this brush to be in contact with this wire, right? And then again, when the coil comes to this position, again the direction of the current changes, and again we want this brush to come in contact with this wire. Probably we already learned that for every half rotation we must change contacts between brushes and wires. But how do we make this process happen automatically?
Okay, so automatically we will use the commutator, which is split ring commutator.
Split rings, as the name suggests, is a ring that is split in between, giving two half rings.
Okay, it's like two half moon like that.
Now let's see how the split rings automatically change contact for every half a rotation. So right now this brush is in contact with this half part of the split ring, violet color. When the coil rotates and comes to this position, the direction of the current changes, and this brush now is in contact with the other half part of the split ring, pink color. This arrangement provides that current flows in the same direction. Again, as the coil comes to this position, finishing another half a rotation, you can see that this is only changed contact. The brush is in contact again with the violet color half part of split ring. In this way, the DC generator is built, where the current only flows in one direction through any external circuit, and in this arrangement, with brushes and split rings, which helps us to automatically change contacts, we call them commutators. So split rings act like commutators. The next thing we must mention, and it's really important for working principle of DC generator, is how can we determine the direction of the current, magnetic field and force. To determine all this, we must use Fleming's right-hand rule. So we will explain how can we use Fleming's right-hand rule. As you can see, the rotation of the coil is clockwise, and the force acting on part of the coil A and B pushing that part of the coil upwards. So to know the direction of the induced current, we apply the Fleming's right-hand rule. How do we do that? We place our right hand so that the thumb
because we know that one part of the coil sure it will move down, one part it will move up. Okay, so because one part up, one part down, okay, the rotation it will in the same direction, and because of the commutator, it will allow the current to flow only in one direction.
So the rotation of the coil is clockwise, and the force acting on part of the coil CD pushing that part of the coil downwards. The thumb points down, indicating the direction of the force. The index finger, or for the finger pointing in direction of the magnetic field, from north to south, and the middle finger will point in the direction of the induced current, which is in this case from C to D. So to conclude, the induced current follows the path ABCD of the coil. The effect of the split ring commutator.
Okay, so can follow here. Okay, so you see here, this one is like how case 1 and case 2, okay? Which means that we must know that one part always it will go up, okay? Sorry, if let's say it start with the vertical like that, one part must be going down and one part must be going up, okay? Because when you move like that, then only it will induce current, okay? Okay, then because of the split ring commutator, it allow the make sure that the rotation is always in one direction. And when the rotation is in one direction, then the current flow will be in one direction as well. Okay, so that's why you see here, okay, you see here, okay. Okay, so this one, okay, so this one is going up. Okay, this one is going up. Okay, if our force is going up, then this part is is going down. So if let's say one up, one down, then we are able to identify the direction of the current using what? Using Fleming's right hand rule. Using Fleming's right hand rule. Okay, when this part AB is going up, okay, AB going up, okay, then the north to south, okay, so the current is flowing from A to B, from A to B. Then in the next part CD, okay, the coil is going down. The coil is going down, then north to south, the current is moving from C to D. Is moving from C to D. So that's why the current is moving from here to here, then come back here. It is always flowing in this direction. Okay, when it's turning like this, it's turning back like this already. So which means that CD in towards north there already, AB towards south there already. But please don't forget, at the north part there, the force always moving up. The force always moving up. So when the force is moving up, okay, then the south there is moving down, okay, the direction of the current still will be the same, okay, by how? Okay, if let's say it's going up, then north to south, yeah, the current will move from D to C. The current will move from D to C. Then if let's say at AB there, okay, the force is going down, okay, north to south. So the current is moving from B to A. So it's actually, you can see that it's in the same direction as the case 1. Okay, as the case 1. Okay, case 2, okay, case 1 and case 2 is the same. So that's why, because of this commutator, it allows the coil to move in one direction and also the current to flow in one direction. The current to flow in one direction. Then that's why we will call this as DC generator, produces direct current. Okay, induced direct current. Okay, anyone got any problem with this or not? Huh? Anyone got any problem with this or not? No, okay, very good. Okay, now we will look into AC generator. Okay, you see here, this one is the DC generator. So if let's say it will start with vertical. Vertical, it move 90 degree, then it will produce the maximum current. Okay, then another half turn 90 degree, because now it's vertical already. That's why it will add the 0 here. Then another one, it turn another 90 degree, horizontal again, so it's a maximum one. Then another 90 degree back here, then because it's a vertical, then it will be 0. So it shows that when the coil is in vertical, no induced current is produced. Okay, no current is induced. The current only induced when the coil move in horizontal position. Okay, move in horizontal position. Okay, so this one you must know the direction of it. Okay, you must know the direction of it. So it's better later on you better copy down. One is that when the coil is in horizontal, the induced current is maximum. If let's say it's a vertical, the induced current is 0. Later on, I will let you copy down it. Okay, can I? Okay. Now, because the movement is in one direction, okay, the commutator allows the current to move in one direction. That's why it is a DC generator, okay? The generator produces direct current. Okay, anyone want to talk anything? Someone on her mic. Azlin? Okay, thank you. Okay, so now we will move on to AC generator. So AC generator, it will be different a little bit, but the coil is still moving in one direction. And because of the two slip rings, it allows the current to move, okay, to rotate periodically, okay, to vary periodically, okay?
AC generator. Today, electricity has become an important part of our life. At home, we need it to run the appliances like electric bulb, television, refrigerator, fan, etc. And in the industries, it is used to run different types of machines. An AC generator is used to generate electricity at various power stations like thermal power stations,
nuclear power stations,
hydroelectric.
However,
Okay.
an
AC generator can also be seen at home, which is used during power outages to keep the appliances like fan, refrigerator, etc. working until power is restored. Let us understand how an AC generator produces electricity. An AC generator is a device used to convert
So the
mechanical
important part
energy
is the
into
slip
electrical
ring.
energy.
Because of the
It
slip
was
rings,
originally
it
designed
allows
by a
the
famous
generator
physicist,
to produce
Nikola Tesla.
alternating current.
Working of an AC generator is based on the principle of electromagnetic induction. According to this principle, a change in flux linked to a coil induces an electric current in the coil. The direction of the induced current in the coil can be given by Fleming's right-hand rule. Lenz's law can also be used to find the direction of current in the coil. Let us now see the construction of an AC generator. An AC generator consists of field magnets, an armature, two slip rings, and two carbon brushes. The poles of field magnets are concave and cylindrical in shape, and therefore produce a radial magnetic field. Armature is a soft iron core on which a coil having a large number of turns of copper wire is wrapped. The two ends of armature are attached with two slip rings. These rings rotate with the coil. The slip rings are made of metals and are insulated from each other. Two brushes are made of carbon. One end of each brush is in contact with rotating slip rings, and other end is connected to an outer circuit. A galvanometer is connected in the outer circuit to show the deflection due to
Okay, you see, every time it is connected to a galvanometer, it's not a battery, okay? Battery is to produce the force, but if for say electromagnetic induction, it will be galvanometer.
Shows that the induced current is alternating.
You see the needle is moving here and there, okay? It shows that the AC generator produces alternating current. The current is flow in alternate direction.
Therefore, the flux linked with the coil keeps on changing with time. As a result, an EMF is induced. This in turn induces an electric current in the coil as the two ends of armature are connected to an external circuit.
You can, if you look at it clearly, okay, when the coil is in vertical, you can see that the galvanometer is in zero reading. But if let's say it's horizontal, it will move maximum to maximum. Because the coil is cutting the magnetic field.
More clearly, let us mark one arm of the armature as green and the other as pink. As per the Fleming's right-hand rule, the direction of current in the arm marked as green is outward, and in the arm marked pink is inward. After rotating half turn in anti-clockwise
well,
direction,
to know that one part sure it will go up, one part sure it will go down. Okay, that it will be easier for you to remember.
The direction of current changes, and as a result, alternating current is generated. If we plot a graph between the induced EMF and time, we will observe that the induced EMF shows sinusoidal behavior. It can be seen from the graph that the direction of the
compared to AC and DC, DC only flow you see the voltage graph it only flow in one direction. But if for AC, it will go up, down, up, down, like that. Okay, so you see the difference between AC and DC is AC is using two slip ring here. One is connected to each part of the armature. Okay, this one is to AB and this one will be to DC. Okay, so as we know that the coil always one part it will move up, one part it will move down. Okay, up. Okay, one is up, one is down. Okay, so it allows the current to flow. Okay, in the same direction. Just that because of the slip ring. Okay, because of the slip ring, the current it will be allowed to flow in a different direction. Okay, so we see case one. Okay, case one, you take note that this part, okay, is connected to AB. Okay, this part, the second slip ring is connected to CD. Okay, first ring is connected to AB, second ring is connected to CD. So one part will go up, one part will go down. So the current flow will be using Fleming's right-hand rule to identify it. One part it will be AB will be go up, CD will be go down. Okay, so the current flow it will be like this. Okay, so this is the current flow. So if let's say go here, okay, you see the armature is connected to the second ring. So at the second ring here, over here, over here, over here. So the current is flowing from left to right, from left to right, okay, from left to right. Whereas if let's say now it is turning 100 degree already, okay, 180 degree already. So it causes the CD to move towards the North Pole, AB move towards the South Pole already. Then you see here, now you see the ring CD is still connected to the second ring. The AB is still connected to the first ring. But now the current is still flow in this direction. But you see here, until here, okay, from the AB here, the current, the induced current will flow from AB then to the load, okay, then to the load here. That's why causing the current to move from right to left. Just now it's from left to right. Now it's from right to left. Okay. Then it shows that the current is alternating moving. Okay. One is moving in one direction. The next one will move in a different direction already. One up, one down, one up, and down. And why is it will happen like this? Is because of the two slip ring. Okay. The one part CD sure will still connect to the second ring. Okay, AB still connect to the first ring, and because of the rotation, okay, causing the current to able to flow in a different direction. Okay, can get it here or not? I think the video just now is quite simple and yet clear to understand. That's why I choose this video. Later on, I will re-upload this slideshow because the previous video I uploaded is a little bit difficult for you to understand it. Okay? Can follow here or not here? Okay? So this part, you must know that for AC and DC, why is it different? Is because they are using two different commutator. Okay? So if let's say DC, what commutator is using? DC, what commutator? Correct, is using split ring. Then if let's say it's AC, then it will be AC is what? Okay, correct. AC is split ring. Okay, so this one you must understand it. Okay, good. So you see here, if let's say it's a horizontal, it's a vertical, then it will be in 0. Then once it move 90 degree, then it will be at the maximum. Then another 90, move another 90 degree because it's vertical already, 180 degrees, so it will be 0. Then another 90 degree become 270 because now the coil you see initially is like this. Now it becomes like this already. Okay, this one is the back here. Okay, this one is the back here. Now it is in front already. So it's allowing the current to flow in a different direction already. That's why the current is going down. Okay, then going up like that. But the induced current, the magnitude of the induced current for the upper part and the lower part here, it will be the same. It will be the same. Just that the direction of the current, one is flowing from left to right and one is flowing from right to left. Unlike direct current, the DC generator, it always will flow in one direction. Okay? Can So I want you to copy this down. Okay? I want you to copy this down as your notes number. That okay, when the coil is in horizontal, the induced current is maximum. Then it's vertical, then it will be 0. Okay? This one is notes number 10. Notes number 10. Okay? And by the way, please use this MCO period to do everything of your passable. Okay, do everything of your passable. if you cannot do the essay question, which is means that the paper 2 question 9 to 12, then you don't need to do it. It's okay. Just that for paper 1, paper 2 section A, and paper 3, okay, paper 3 maybe section A, okay, you do everything, okay, no need to wait for me already, just do everything, okay. Maybe essay, must draw magnetic field. What do you mean by must draw magnetic field? You mean the diagram here, is it? No need, diagram no need, okay, diagram no need, okay. I just want you to know that for the coil, if let's say it's a horizontal, the induced current is zero. But if let's say it's a vertical, the induced current is zero. But if let's say it's a horizontal, it will be maximum because there is a cutting of the magnetic flux. Okay. Can I continue already? Yeah. You mean this diagram? Depends. So at the moment, past year, what I see is that they haven't give you this kind of question, but you must know about it. Okay. Okay, so let us continue. Okay, so you see direct current, the current is flow in one direction. Okay, the current is flowing one direction. So one of the example of direct current, it will be easy. It is battery. Battery, because you see, battery, you must connect it into the same positive terminal to the and negative terminal, then only the current will flow. Okay, but for alternating current, for example, the power supply, every time the power supply we use in our experiment is AC current, that is allowing the current to flow in two directions. Okay? And direct current, okay, if let's say it's not, just now I let you see the graph, okay? The graph is like this. Okay, the car, if let's say it's a direct current, it is like this, then like this, then like this, and like this. This one also showing that it is direct current, okay? But if let's say it's a straight line, also is showing that it is a direct current because the straight line means that the current is flowing in only one direction. Then the blue one, it will be alternating current, alternating current. So I want you to write this, draw this diagram down as your notes number 12. As your notes number 12. Okay, so it's better you draw also the one with the curvature one, okay, the curvature one, but you take note that that one is also a direct current. Okay, depending. Okay, if let's say they give you a CRO, okay, they give you CRO, okay, CRO, not 11, not oh sorry, 11 okay, okay, sorry, it's 11, okay, 11 Okay, if let's say they give you a CRO connected to the X terminal and the Y terminal, then you will draw the one with the curve one. Okay, curve one. But if let's say they only give you the Y connected to the Y terminal, then you just draw in a straight line only. Okay, but actually both also it is the same. Both also it is the same. Okay, in exam you draw either one also can. Okay, you draw either one also can. But if let's say the exam give you like this, okay, the one in the blue, then they want to tell you, they want to ask you draw a diagram to show that the alternating current changing from the direct to direct current, then you draw to this. Okay, can follow? Angeline, can I? Okay, can I continue? The line intersect at x is what value? Draw what? This one lah, the whole thing lah, Sasmita. Okay, the light. You mean this intersect, is it? Jane? Oh, okay. It doesn't matter any intersection. What is the value? I just want to let you see the flow. I mean the pattern of the card, the alternating current and the direct current produced in a CRO only. Okay, it doesn't matter the intersection one. Okay, if you don't want to put any intersection, also can. Okay.
Teacher,
Hey, sorry.
very curious about one thing.
Yes.
The galvanometer like deflects to the right and the left got any meaning one? Like right is what, then left is what?
You mean for alternating current or direct current?
I think it's alternative current.
Alternating current okay, if let's say
Yeah, just now I saw one.
you see like this okay, if let's say it's a galvanometer this one, the galvanometer flow like this, which means that it's flow in one direction. If let's say the galvanometer like this, that is flow in a different direction, and this only you will see this happen in when it is connected to an AC generator. For DC generator, the galvanometer, any rotation also, it will also flow in one direction. Like that. If let's say of alternating, then you will see that it's flowing like this, like this, like this, like this, like this. Actually, it's like this. Initially, it's like this, then flow here. Then go back to 0, then flow here. Like that. But for direct current, you will see that it's flowing like this, then like this, then like this, or like this, like this, like this. One cycle is what it's actually like the wave lah. We have learned in our chapter 1 already. Like this is considered as one wave. One wave means that it's considered as one cycle. Okay. Angeline, did I answer your question? Okay. Okay, thank you, Zira. Wait, think so lah. Okay. The deflection of the galvanometer also is telling you that it is either a AC or a DC. Okay. 1 minute. Okay, now I still a little bit left. You all go out from this meeting already, come back here again. Okay, because only 1 minute. Okay, see you later.